A few words about me and Devicetree, which you can see there. I started kernel hacking in 2008, pretty soon on PowerPC, and on that platform. That was the first one to have Devicetree, and when we hacked on that, it was all pretty new, and we were trying out things. Later, I switched to ARM, and the Devicetree haunted me. It came follow me after that. Why I mentioned this is it feels different now. When we were hacking back then on that, it was new, and we took the time to find out things. And at the moment, it feels very intense. There's a lot of interest in Devicetree, and people want to get their boards out using Devicetree. And sometimes this creates a pace which is pretty high. And when you have such a stumbling block, I want to mention a few of those. It makes it pretty hard to find the correct solution when there's also this desire to get the boards out, the pressure to deadlines. So I know both sides. I know the quiet time back then. I know the more busy time right now, and I know also both sides from being a developer, just working with Devicetree, and the side of the maintainer who has to accept patches dealing with Devicetree. I just want to show a simple snipplet to get an idea what the problem is. So this is a description of the custom typical I2 sheet log. You have a compatible entity to match it to the driver. It has some registers and an interrupt. This is basic stuff, nothing special about it. The thing is that people are working with Devicetree, and this is mainly here about converting drivers from platform data to Devicetree support. That needs some kind of conversion, and involves adding extra configuration. So what you can basically do with Devicetree is add another binding, another property, just for as an example, to debug level here and assign it some level. And the only thing you have to leave in the code is basically you have to call this helper function with that binding you just invented, and pass the value you got into a variable you just used, and you get the device mode where to catch the data from the Linux kernel. So it's not much code involved. It's pretty easy to get data out of the Devicetree. And that's a problem. It's too easy. So people use it in various ways. And like I mentioned before, the problem is that we have to convert drivers from platform data to Devicetree. And platform data is different. I want to express two major differences between platform data and Devicetree. The first thing is that platform data is totally embedded in the kernel binary. So we could somehow call it an internal API. If you want to change something later, as soon as you make sure that all users in the kernel are prepared for your change, you take care that the users and the provider of the data are all updated so the change is consistent throughout the kernel, you're all done. You can do that with platform data, because if you update the kernel as a binary image, you update your new handling of the platform data. If there are out-of-tree drivers or platform support or whatnot, it's usually common sense to consider bad luck. Well, if you're out of the tree, you have bad luck, and I think this is the right thing to do. One key feature I wanted to mention here is platform data. The other one, since it's an internal API, you can pretty much use it for anything. You can encode what GPIO do I need to reset the device? What is the timeout for some action? Do I want to use DMA or not? This is, I don't know, you probably know that from platform data. It can be used in various ways. Devicetree changes that a lot. Yes, we have a lot of Devicetree inside the kernel source as a reference. but it does not mean that all the data encoded in the device tree is also in the kernel binary. That can be external. They can be put somewhere where the bootloader decides to put it. It can be, I don't know, it can be even come from the network. If you do rapid development, it might make sense to get the device tree over the net. You may even have, which is rare, but you can have a board which has an open firmware BIOS, so to say, which generates the device tree at runtime. So the assumption that if you change all device trees in the kernel and the usage of the device tree data in the kernel, if you change that at the same time like you did with platform data, everything will be okay, is in my opinion wrong. And back in the day when we had with PowerPC, people were very careful about that once you set up a binding, some kind of external API, you have to support that forever. And I was surprised to hear that some developers had yeah, try to come in. I like to spread the topic, so somehow feel comfortable. Please come in. So there were some developers saying that, okay, if I change the code and all the device trees in the kernel, then I'm also okay. And I don't think this is true. I don't think that should ever change. So if you update the kernel, you must be sure that it still supports the old device trees. Pretty important. And device trees are being external thing, they have to be agreed on, and the initial idea of the device tree was it's a hardware description. So you can't have as broad usage as you had with platform data. It's a platform, it's a hardware description, and it's OS independent. So it should be possible that you, with the same device tree, you could boot a BSD kernel. That is also important because a lot, especially when converting platform data, you easily get assumptions about Linux internals or want to use Linux internals and map that to device tree bindings. Strictly speaking, this is a no-go. It's at least problematic. So, to repeat, because it's important, changing platform data for all users in the kernel and the way you handle it is okay. Internal API, out of 3 boards, bad luck. Changing device tree for all users in the kernel tree is not sufficient. You have to be backwards compatible. And this is why I'm especially pointing people to be careful with inventing new bindings. It's easy to add a new field to platform data, but new binding is a different game. Think of it more as adding a syscall than adding platform data, because I probably hope that if you had the idea of adding a syscall, you would be very careful to think about how to do it, and of course also be very generic. Make that syscall in a way that a lot of use cases are covered, and that should be also true for bindings. If you convert a driver and need some data, think about how other drivers might need, do they need the same information? Can we encode it in a generic way? And that could easily be extended not only I2C driver, is it useful for any driver? That's one part of the problem. So I want to get to some examples now, which I really had during the last recent months in the I2C subsystem. Here is an example of platform data we have in the kernel to set up an I2C master controller. It's not much. Some 2 frequencies, M and N, or whatever they are named, I don't know, and some timeout value. And the board description set up is M and N, and then you had working I2C. Hooray. This driver now wanted to be converted to device tree. And the first patch, by the way, I'm not bashing anyone when I say, okay, I got this patch and it was all wrong. I mean, I understand. Most people are thrown into cold water and they need to try to do as good as they can. So it's not really about bashing it, it's just about giving examples. The first patch I got was, this is a part of it, and this was the description of the bindings, and the code was matching this description. And you can see here, you see the frequency m again, which was taken from the platform data, frequency m and timeout. In your opinion, how generic frequency m and n is? Do you think this is acceptable? Who thinks this is acceptable? Yeah. No, I couldn't take this one. In the next driver would have frequency A and B, and another one is in Y, and it would be a complete mess. Frequency M and N is used to define the speed of the I2C bus. At what speed do the slaves and the master talk to each other? And we already have one binding for that, and that's called. Okay, that's what was done here was it was a one-to-one mapping from the platform data to bindings. That's almost always a bad idea. Do not do this. Look for generic solutions, and that's what we were saying. We have a binding which is called clock frequency, and I made the author to adhere to that clock frequency. So he had to change the code and needed some kind of function like this. From a given frequency, where the user said, I want this frequency calculated, now we find the n and n factors here again, but they need to be calculated. That was what I was requesting from the author, and honestly, this should have been there with platform data as well. I think the board authors with platform data would have been very happy to just specify the frequency they had instead of looking up in the manual which m and n they had to use. So this was a good thing in the end, and with that binding and that extra code, the patch went in quite smoothly. But this original patch also had another binding. It's timeout in S per millisecond. How long to wait for a transaction to complete? This is a bit tricky with I2C because you might have, I don't know, some user or polling device which really can take seconds to fulfill a transaction, but sometimes for most devices it's a timeout if they don't respond after a certain time. So the first question, do you think this is a proper binding? Who thinks this is a proper binding? Oh, nobody. Who thinks this is not a oh, Rafa.
Just for the sake of it.
Okay. Who thinks this is clearly not a correct binding? 2. 3. Who feels puzzled? Okay, maybe you can understand my situation a little bit. I tend to think this is a binding, because it depends on the I2C slaves connected to the bus when this timeout happens, and this is hardware related. From that point of view, you could see this is a binding. I see Lauren is saying
it should be property of the slave.
Should be property of the slave. Yes, that would be perfect. Other than that, I grabbed all the existing I2C drivers and find, ooh, there are already people doing this already. So these are taken from the bindings documentation from the current Linux kernel, and you find that the FSL driver already has a custom binding prefixed with FSL, and the GPO driver has one prefixed with I2C GPIO. These are weak bindings because they're not generic at all. They're missing the idea of trying to do this in a generic way. They had just had their problem and wanted to have that solved pretty fast. The drawback is, as I said before, we have to support these old device trees with possible forever. So as soon as we have such weak bindings, we have to support these weak bindings forever. That's why I'm not happy with them. They're already in the kernel and we have to support them, although I don't like them. This question about the I2C timeouts is not solved up to yet, because the driver author took the easy, I can understand that perfectly, the easy path and said, okay, I'll just hard code it to 1 second, that will do for most, and leaves that to somebody who really has it. That is a valid solution. What I want to show from that example is custom bindings are usually a bad idea. You know, this FSL dot timeout, comma timeout, or I2C comma timeout, just to handle your own case. It's usually a bad idea. The good thing is that Devicetree usually enforces generalization, not only across one subsystem, but also across all subsystems. The drawback is, that's good, but who does the work? How much can I ask of the driver author to do that? How much is my obligation as a maintainer to set up this for my subsystem? How much work is it for the Devicetree maintainers, because they should have the overview for all subsystems? And you can bet, this is just one example, this is just a few examples of the I2C subsystems. There are a lot of other subsystems who may have similar problems. You can imagine how busy the Devicetree maintainers are. So this is one reason why Devicetree conversion patches can cause some delay problems, extra rounds, and this is yet to be dealt with the timeouts. DMA. We all want DMA, right? It's fast. Does anyone, somebody have a comment about this binding? There's a question if there's existing some binding already. That's a good question, because that's what we surely want to have. DMA channel is nothing special to the game. DMA channels are all of every SLCs, and we surely want to have some bindings. And here it's a custom binding, which I also didn't like, but I found out that this binding also made its way into the kernel for others. So the binding was also already used for the SPI core and other cores for that specific SOC. So in the end, I accepted it to not delay that SOC or the I2C. But I'm not happy with it, and so I wondered, where are the DMA generic bindings? And I was pointed to it, and I looked a bit for it. It's nice that there are some, and the people, they also have gotten some serious thought into them, but they started in February, and there was some activity in September again, and they're still not in Linux Next. And what happens, people want to push out their boards, they want to meet the deadline, so I haven't grabbed for it, but I can imagine we have lots of strange DMA bindings in the mainline Linux kernel we have to support forever now. And I really wonder about that, because that's, I think, a pretty important part of the infrastructure. And I'm a bit at a loss, so is it not the problem of not enough manpower? Seeing how much things shift in the ARM world, in all kinds of fields, I wonder if that's really the case. Is that not enough priority for that part? Because, well, we can have custom bindings, it will work somehow. Is it really such complex solution that it takes 6 months to fulfill the DMA bindings? I haven't read through all the threads, but I tend to think if people concentrated on that, they could go pretty easy now. A lot easier in a short time. And then there's a problem, and there's developers who wants solution because they need DMA. DMA is a pretty crucial component of SOCs. So, what should I do as a maintainer? If I take my role as a maintainer who says, okay, I want a good kernel, I want the best operating system in the world, and I want a sustainable code base, and this is not sustainable, I somehow feel the urge to reject such patches and say, no, sorry, that's not going to cut it. Increase the pressure to get these DMA patches to the mainline so we have a proper solution. But then I'm the one, other people took the patches, so I'm the very evil I2C maintainer who's blocking everything. People start yelling at you, and they do yell at you. Makes you feel bad, and it doesn't help the situation much if you block complete SOCs out because they don't have I2C. People could say, okay, if it's so much important, it's of such importance to you, then start working on the DMA patches. But hey, if I should do this for every patch or patch set I see, which would help such situations, I would be busy doing millions of patches, and I'm, strictly speaking, personally not much interested in this. Trying to help the infrastructure. That won't cut it. I'm not able to do that. So this is one of the situations which I see as problematic. I basically think it's a problem of manpower, and by doing such talks, I hope to get more priority to the subject, so there's more manpower put into that, so we finally have solutions. Because I will never say that Devicetree is a bad thing. It's the thing we have, and we can do. I think we can do nice things, but we have to do it properly. Better we do it now, not later. And this is a combined effort. Okay, I switched out of I2C a little bit. This is a patch for USB, but I came to see it because it's one of my colleagues. I have to train my colleagues as well. Somebody feeling like commenting on that? Just want to mention here, he adds some binding, and he removes the static platform data where you can see where they carry the bindings came from.
Well, definitely the documentation needs to be improved.
True?
The documentation needs to be improved.
Yes. Yeah. The documentation is really horrible. It says basically switch it on or switch it off. That's one thing. You can clearly see one-to-one mapping again, which should always make you think. Yeah. And what I quickly, after 1 minute of grabbing, found out that there is already a special way of describing transceivers. There's separate nodes. So you could really skip requiring transceiver by checking if the node is there or not. There are other ways to find out. And when I was asking my colleague, what about those? When are they needed? What do they do? He basically replied, oh, well, I saw they're a bit, so I thought it might be good to switch them on and off. After asking him if that was really needed, he grabbed through all the users in the kernel, and I said, no, there's only one combination of the bits which makes sense for all current users in the kernel. So that could be hard-coded. And like we had that a few slides ago, that was the solution here to drop them entirely and hard-code what you need. And leave the problem if that needs to be switched for later, if somebody really needs that. So a few suggestions we all had already: go to one-to-one mapping, use existing binding. Then what I said, don't convert what you don't need. It's nice to explore all the options in what you have. Keep it simple. Try to not invent bindings. Not inventing bindings is better than inventing them. And also sometimes it's a bit related. We have implicit information from the compatible binding. if your driver gets called by, for example, being an I2C driver for IMX23 or IMX21, it's a separate binding, you already know, okay, which erratas does this or that one have. You don't have to encode that as a binding. That's quite useful implicit information, which you should use. Because imagine someone doing a Devicetree file for a complete board. Why should that person encode what words the I2C controller has? So it's no use in doing that. So that's also something to keep in mind, that this might be a valuable source of information. Oh, my favorite one. Use PO. Use PO transfers instead of DMA. For I2C, there might be reasons to do that. Setting up a DMA transfer requires some overhead. And if you just transfer lots of small messages, it might be more efficient to use PO. Is that a problem either? Ben?
No, because you should just say, just don't specify the DMA channel in the first place. Why you specify a DMA channel in the binding when you actually don't want to use it?
You're saying, if I specify a DMA channel, then use it. If not, then
Makes sense. It's a policy decision. It's not a bug problem.
it's a policy decision. Yeah. That's the main problem. It's some kind of conflict. Yeah.
It could be that it's because of hardware, but in the SOC, that you have to use PIA for that particular thing.
Yeah, but that get with a compatible property, then you could find out which IP version you have and then disable it.
This is the core problem here. This is some kind of driver configuration. So my idea is also it should not be binding, but it's a problem which will come back again and again because people want to configure their drivers. If you don't have platform data anymore, this is going to be a problem. And we need to find solutions for that. I had the idea, exactly the same idea like Ben did. Define a DMA channel. If a DMA channel is defined, use DMA. If not, then let the driver, remember, it might be a Linux driver or a BSD driver. Could work totally differently. Let it decide what it should do. That could be fallback to PO. That might work in that case or not. There have been, not everyone like that idea. This needs to be discussed. But we should be prepared that there are a lot of people wanting to configure the drivers and invent bindings. And we need to find good ways to deal with that without polluting the bindings. And this is why I also encourage you to keep that in mind and also to talk to other people about that. Because, as I said, to me it feels, the bindings came in very rushed. So I'm not surprised if there's... I have background, coming from the PowerPC era and working with that earlier, I have background and I can say yes, no, please let's talk about that. But I wouldn't be surprised if there's some subsystem maintainer maybe dealing mostly with PC hardware and now seeing floods of patches coming with Devicetree conversion. Looks like most of the others should be okay. No offense, I mean, what should this person do? It's pretty hard to get, as I said, the Devicetree maintainers are overloaded. It's pretty hard to get support. And hey, can you have a look at that bindings? Are they okay or not? And I also think you cannot expect the Devicetree maintainers to have a look at all the bindings and for all the drivers in the Linux kernel. So we need to find ways to deal with that. And I think more manpower will surely help. I'm very happy that a lot of people are here and listening to me and maybe agree at one or two points and start paying attention to that point. Yes.
How does PowerPC deal with the driver configuration?
There are old bindings coming from that era in the kernel which are plain horrible. which should have not been there, which have to be supported forever. And a lot of things are hard-coded, let's say. I haven't been following for the last 2 years, maybe, PowerPC in close detail, but back then, a lot of the configuration was hard-coded until somebody needed to change it for whatever reason. Back then, if not something needs to be changed, the idea was to have a generic binding, and there was a focus if it's a hardware-related binding, how to map the configuration to some hardware setting, so you can have an argument to have that in the last few, like not specifying the duration or similar. But I have to say that some problems simply didn't get unnoticed so far because the ARM user base is by magnitude bigger than the PowerPC user base. So the problems show up now. And yes, that was the stuff I prepared. I wanted to leave room for questions. Maybe we have a microphone.
I can just talk loudly. So for a long time, the kernel policy has been the kernel to user space ABI is backwards compatible, but inside the kernel we keep the freedom to change whatever we want, to reorganize code, refactor drivers, subsystems, and so on. So keeping a lot of freedom inside the kernel. So now with this Devicetree thing, we are adding an additional ABI that we need to keep backward compatible. I'm just wondering, do you think it's worth the effort? Isn't that going on the long run going to add too much constraints on the evolutions of drivers and subsystems inside the kernel that will make it difficult to maintain those drivers and those subsystems? Is that backward compatibility promise at the Devicetree level actually going to be really useful in the field and enough useful to make it needed to support this backward compatibility pain on the long run?
Did you understand the question, or shall I repeat?
Please repeat.
So the question, to sum up, will the backward compatibility of these bindings take too much of our freedom when you're doing device drivers regarding we can change things like we want? And do I think this is worth the effort? I don't spend too much time thinking if it's worth the effort because it's there and it will stay. I don't want to fight the mills, you know. So my idea is, okay, it's there, how do we deal with it? I mentioned the positive aspect I see. It's like to focus on generalization, which was sometimes too easy wiped away when doing platform data because everyone could do like what you want. So I think this is a good thing. If we handle this configuration issue conveniently, then I don't think there will be much drawback. If you still have the idea to be somehow a way to configure drivers and set up the boards as you want, then I think it's worth the effort because on the pro side, again, it's really nice to have one static kernel and you just pass it another device tree and it will just boot. That's a good thing I'm looking forward to in general.
For the DMA or programmable input-output option that you quoted, wouldn't there a sysfs file or a debugfs entry point be the right solution? Because this kind of stuff is sometimes for performance, but sometimes for debugging. When I port the driver to a new system on chip or a new board, I need to turn on and off the DMA. So maybe the Devicetree is not the right answer to the problem. It's a question.
So the question is if
If,
how to the DMA configuration at the device tree level, can I do a sysfs file configuration?
If some of the bindings that are usually passed in the device tree can actually be made a SysFS or the BugFS option for
Well,
flexibility.
To me, sysfs is another kind of API. So if I'm imagining that people put all the platform data into the sysfs, I get a no inside my brain. This is not what I would like to see. The perfect solution for that case, for example, could it be check the size of the transfer, and depending on the size of the transfer, do DMA or do that. Sadly, the hardware was so broken that we couldn't do that. That would have been the perfect solution. But to answer the sysfs thing, don't have good feelings about that.
Right. Actually, I have a couple of questions. The first one is, now we're passing in data to the kernel.
Can you speak up a little bit, please?
Now we're passing in device trees to tell the system how we're configuring our hardware. It makes life difficult when debugging a problem with a customer saying, okay, we've got kernel version this, but actually what device tree did you pass in as well? Because you need to know both things to actually say, is this driver malfunctioning or did you configure it badly? So it's sort of two moving targets instead of just one when you're looking at debugging issues with hardware. Is there any solutions to this that you can think of?
You can get the device tree from the file system, and then you can go with the special device tree.
Can you repeat? I couldn't. It was probably right, but I couldn't hear it.
You can fetch the device tree from the running kernel and tell the customer to fetch the device tree, give it to you, so you can analyze it and compare it with your device tree, see if the driver is properly configured. So you can eliminate this problem.
Yeah. Is there any standard organization which can take care of these bindings? So at the end we are operating system agnostic, because I think that's the point. Why don't we add a third party that says what is standard, what is not, what is a binding, and also maybe add versioning to these things. Saying for every node in the device tree, we can say we are compatible with this kind of hardware, and we are this binding. We are binding 1.0, and then the kernel will say, okay, unfortunately I don't support this version for this node. I only support version 3.0. So please upgrade or downgrade your device tree. I think that would be perfect.
There's an organization who puts out it's called paper or what? So there is the list of that. I would think it's too slow in coming up with solutions. To be honest, I don't really know the interconnection between this organization who brings out that paper and the how official that really is. I mean, if there's something written in that document in paper, it's considered official, but it's pretty rough. And I have the idea it's meant to be this rough, and some details are defined then on the operating system level. I generally think how long such organizations take to make some decisions. I think it's too slow. It would be nice for the developer's point of view, because then you could refer to that. I also have a lot of, it's not entirely clear to me, because a lot of bindings at the moment are invented at the Linux kernel level. Being operating system independent, we're creating facts, other people have to live with it. In a perfect world, this is also not the perfect solution, would not be the perfect solution. It's just happening because we need it.
What about just for the startup, adding a version for every node? That would make everything easy.
What for everything?
Add a version for every node.
I think it would add complexity. We lost track of your. Who feels next?
I just wanted to add something.
You want to add something?
About the versioning. As I understand it, the plan was to have at some point the bootloader provide the Devicetree, and there was anxiety about that in normal cases on embedded devices the bootloader isn't exchanged so easily. So therefore the necessity to that the kernel says I need version 3 point something instead of the version 1 point something the bootloader provided won't be possible, because you can't easily upgrade the bootloader without having causing problems for the device users that have to do it. That's something I got about the earlier discussion about.
At least you know if something went wrong. If your device, if your firmware
that was if the binding is out in the wild, you have to support it. That's what we said in the beginning. If you have published it, it's there. You have always to support it.
But we can also have the other way around. We can have the thing.
I'm happy that you go into discussion, but I want to ensure a variety of discussion. I was tempted to make a buff about this topic as well. Sometimes please.
Little one question. Small.
I just want to say, please do continue this discussion, and I want to go to the next question. But please don't stop.
I want to ask you what's about Devicetree support in bootloaders. Do you know something about Devicetree support in the existing bootloaders?
Yeah, it's existing. It's existing.
It's existing. Can you enumerate the list of the bootloaders that supports Devicetree?
I know mainly two bootloaders. That's U-boot and Barebox, and they both should have support.
And for bootloaders that don't support Devicetree, you can append the Devicetree to the kernel image, like you can with a RAM disk.
I think it's mostly about bringing the Devicetree support in the bootloader, because it's had some initialization for which Devicetree supports it, and the various complicated portions that in this kernel and for the bootloaders, and I think Devicetree can be very happy.
Maybe you come to the back.
We have more questions. 5 minutes.
You mentioned that one of the problems we have is that we don't have enough manpower, and that many subsystem developers are not really aware, or at least familiar enough with the Devicetree to trouble using patches. Has there been any efforts to educate those subsystems?
Can you try to move out widely, please? No, not yet. I'm not aware of a concentration. If there was a concentration, I don't know
That would be interesting to do. Instead of educating all the developers at large in the first step, you could first concentrate on the subsystem data that at least then maybe detects possible problems, flag them, report them to people who are really familiar with the device.
Can you please go out more quietly? Thank you very much. When I was thinking about what could happen in a situation, one of the ideas was to talk about it. Not in the position to organize a conference about it. Maybe I should try.
Definitely. I think it would be interesting.
The first thing I did was doing Please be quiet. Thank you very much.
That the problem actually, to some extent, mainly is I have this problem. I've given this kernel of now I get a problem with port from the customer, and I don't know which device he's running. Why not just as when we do the kernel, we get a build stack and on it, why don't ECC can put in a similar construct there so that I know that at least the device before that started with this one which I know this signal. That would not add any complexity. do something similar to that, but do that actually in the device. I know that the
you can query the device tree from the kernel.
Yes, yes.
So you could
That's what I put it in now in the source, but actually, if it was just a standard thing in the device, I put in a version. So we have, if it comes from a Git repository, then say it's this repository, this file, this version, and then also this script is understandable. Just as we used to that way.
Could we start? Let's start with something like it we discussed today.
There's some kind of version string that we have a proper standard lighting.
Yeah, so if you have a problem, or you know, I have this version of the bootloader, this version of the kernel image, and this version of the PC file, then you might not know what the bootloader is done with it, but you know exactly which version of it.
In trying to resolve the trap between being pragmatic and getting a device tree binding, it's trying to resolve the trap between trying to resolve whether a binding is a reasonable one. You've got the standards will take too long, but pragmatically you have to do something. Is it reasonable to add a standard extra term within the binding, like provisional or legacy or deprecated, or to be reviewed, indicating that it is simply a pragmatism and it's yet to be ratified? Because at least you're not pledging yourself to the past, absolutely, if you accept it. And you are flagging this up as being potential issues, so here be dragons.
Yeah, but that would be like telling, okay, I'm creating binding, I'm putting that in my bootloader, but I know that it's not going to be supported by later versions.
And the danger is, of course, that it lasts forever, that they're all provisional, like all data sheets.
So it's like more or less a useless binding.
Well, I mean, it's not a great solution, but is it better than accepting legacy because you're forced in?
I guess the question is, how long is forever?
Last question?
Yeah, so I've been struggling with the device for the last few weeks, and especially what I haven't found. I'm trying to write Devicetree for PCI, for example, for our subsystem, and now the DOM is pretty new, and the Devicetree there's no other valid examples in the code. So I saw some examples from the PowerPC architecture, but it seems like everything is implemented inside their architecture. And so the problem is that I tried to figure out how I'm describing the PCI interface in our SoC, and it seems like either way I'm going with the multiple private entries for the Devicetree for our PCI interface, or trying to find some generic solution which we don't have currently in the kernel. And we don't have, also we don't have any, maybe just a target description or something for PCI that might help people who are trying to write some bindings for it, even if it's not implemented, just what's the target for it to be pretty generic but allow people to start writing something. So do you think if there's any activity in this area, or what can be done to just make sure that I'm not writing something which is too private for us?
Where can I look if people are working on that?
Yeah. Or if there's any examples inside the kernel for such things, which I haven't found on the PowerPC.
Talking of PCI, I know that there is something in the making with people did a few things with PCI and Devicetree. I was surprised because I thought PCI was auto-probing, so you would not need Devicetree snippets for that, but you need. But other than that, I don't know of the central points. It's mainly about grabbing and using the
I guess the best way is to submit patches and get them reviewed to get out. There's a Devicetree meeting we use for that.
So